Okay, let's do a Diels-Alder reaction from start to finish. Here's our diene, and there's our dienophile. The first thing we have to do is figure out the regiochemistry. A methyl group. A methyl group, as an alkyl group, is an electron donating group. Electron donating groups, what charge do you associate with donating groups? Negative charge, minus, and then we'll alternate as we go through the diene carbons. So plus, minus, plus, minus. This also has a methyl group. Now it's kind of weird to have a methyl group, a donating group, on your dienophile, but it's possible. So we'll just deal with the cards that were dealt. So this is a donating group. It's also minus, plus, minus. Note that if we try to align the diene and dienophile the way they're shown, we're going to have the negative charges and positive charges presented to each other. So instead, we're going to have, we'll leave our diene because it's the bigger piece. We'll leave that as is. We're going to have to flip over our dienophile, and that'll give minus, plus, minus, plus, minus, and that's minus, plus, minus. Now we'll have the positive and negatives aligned with each other. So this is the regiochemistry that we're going to get. So now let's worry about the stereochemistry. For stereochemistry, I told you there's no shortcut. We have to take the diene. Let's number the carbons to make these clear. 1, 2, 3, 4. So we're going to look at these, try to look at them from a more flat perspective. So we're going to look at this. Let's redraw it over here. We're going to look at our diene from this perspective. So we have both our hydrogens poking in, and we need to reflect that. They're both going to get wedges. And on carbon 1, we also have a CH3. It's going to be sticking out to the right. And on carbon 4, we have a hydrogen sticking out to the left. So there's our diene. Now let's draw carbon 5 and 6 of our dienophile. 5 has the methyl group. Let's think about where that's going to go in a second. 6 is easy. It's just 2 hydrogens. Now, what we said about the R group on our dienophile, it always wants to go endo, which would be the back position, because that tucks underneath carbons 1, 2, 3, 4 for that diene. It always wants to be endo if it has a pi bond. A methyl group does not have a pi bond. Therefore, it wants to take the wedge position and get away from the diene as much as possible. So it's a little tweak. R groups on the dienophile typically want to be underneath. That's called the endo position, unless it doesn't have a pi bond. If there's no pi bond, it wants to come stick out towards us, which is called the exo position. So this is exo, and that's endo. And, these hydrogens also have endo and exo positions, but they're both the same, so it doesn't matter. So our R group is going to occupy the exo position. Now, when we do this cycloaddition, we will again make a cyclohexene. Number these carbons. You notice I do a lot of carbon numbering. You should also do a lot of carbon numbering. It's very helpful in this. Let's see. Let's take care of carbon 4. Because it's just hydrogens. Let's take care of carbon 6 because it's just 2 hydrogens. There's no thought there. Now, carbon number 1 over here on the left has a hydrogen being wedged. That means the methyl group must be back. And carbon number 5 has the CH3 group being wedged and the hydrogen being back. And that is our product, accounting for regiochemistry and the endo-exo stereochemistry for this. And I can draw it differently if you like seeing it represented. In a slightly different way, a little bit cleaner looking. And so we will get the trans product in this case. Sometimes you get cis, sometimes you get trans. How do you know? There's no shortcut. You just have to go through all these steps. First figure out your regiochemistry, and then figure out your stereochemistry and draw the resulting product.